Everybody, this is a video for 10.3, which is about two-way tables, which can help us solve some probability-related problems. I guess I should be in present mode. So here is a partially filled out two-way table, and a two-way table is a table that displays data from one source that belongs to two categories. So one category is represented by rows and the other by columns. So the one that's represented by rows is the grade, pass or fail, and then the one represented by columns, or the other category represented by columns, is preparation, so either studying or not studying for what I assume is like a test or something. So when they say the data is from one source, they're just saying they basically asked like a group of students whether they studied or did not study for a test, and also whether they passed or failed that test. 50 down here in the very corner, what that means is that in total they asked 50 students. So this like study or survey asked 50 students total. The reason they don't fill in everything is because this is actually enough information to figure out all the other information, and they want us to figure out the rest of the information. So if there are 50 students that in total, and there are 10 students that failed, that would mean that 50 minus 10 equals 40. That would mean that there are 40 students who passed. Okay, so this is going to be 40, so that 40 and 10 add up to 50. And then also, if there are 38 students who studied, and there are 50 students total, we can find this other one by doing 50 minus 38, which is 12. So there must be 12 students that did not study. So that's how I got those two numbers. Now, how can we figure out these other cells, or these other entries here? Well, if there are 40 students total who passed, and there are 6 students who passed and did not study, that must mean that there are 34 students that passed that did study. So 34. Now, we can use these. So these are like subtotals, basically, within the little groups here. So if there are 38 students who studied in total, and there are 34 who studied and passed, that must mean that there are 4 who studied and failed. And then if there are 12 students who did not study, and 6 of those passed, then there must be 6 students who did not study and failed. So that's how we get 4 and 6 right there. So now our table is all filled out. And there are some vocab terms next that I need to explain. I tried to make the color coding help with these terms. So the entries in red are called joint frequencies. I'm not really sure how the name comes about, but joint frequencies are these ones in red, and they line up with one row and one column. So like this one is like students who studied and passed. And this is students who did not study and passed. But all of these red ones are joint frequencies. Now, there are these like these totals that show up in the table. So the sums or totals of the rows and columns are called marginal frequencies, and they're in blue. So all of these are marginal frequencies because they're totaling up something. Okay, and let's continue on from there. So those are important terms. So joint, these ones in red, are joint frequencies, and then marginal frequencies, these ones in blue. Okay, there are some more terms that we have to learn. So That's just the nature of this. The problems in the book even bring up these terms, so I want you to know what they are. In order to find the joint and marginal relative frequencies, so relative is the thing that makes this different, the word relative did not show up in those other terms, is that we divide each frequency by the total to find the relative frequency. So it's like relative to the total. So the total, overall there were 50 students we asked or surveyed, so everything gets divided by 50, every single item in the table. And then that gives us our relative frequencies. Now, we still separate it into joint and marginal. So here's our table without the work shown. This is just the results, the relative frequencies. Now, we still call the ones in red joint, where they still use the word joint, and now it's joint relative frequencies because they're relative frequencies. Each joint relative frequency represents a ratio. For example, 0.12, this 0.12 in particular, is the ratio of students who passed without studying compared to the total number of students. So another way to say this is basically like 12% of students did not study and passed. And then we still use the word marginal to describe these ones in blue, but now they are marginal relative frequencies. Relative because it's all relative to the total. Everything is less than or equal to 1 once we divide by the total. So each marginal frequency represents a ratio as well. For example, 0.76, this one over here, is the ratio of students who studied compared to the total number of students. So basically, another way to say that is 76% of students studied for the test, or whatever it is they were asking about. Okay, so there's one final term, so sorry, color coding still helped there. There's one more term, which is finding conditional relative frequencies. So relative still means it's like relative to some sort of total, but conditional means it's going to be kind of these like row or column totals rather than the overall total. So divide the joint relative frequencies by the row or column totals in order to find the conditional relative frequencies. So we have to pick rows or columns. For this example, let's pick rows. So we're going to divide by the row totals. So notice how in this row, our old row total was 0.8. So if like I go back there, the row total was 0.8. Now we're dividing everything in that row by 0.8. Dividing here by 0.8, dividing here by 0.8. And then everything in this row we're dividing by the row total of 0.2. So notice that before the row total there was 0.2, we're dividing everything in that row by 0.2. And since we didn't actually use these numbers down here, we're not even going to include them on the next slide. We're just going to think about the rows because we chose to divide by the row totals. So let's put this in context. This 0.85, what that means is that 85% of students who passed studied. So it's in the pass row, so that's how we know it's like students who passed, and 85% of them studied. And then as another example, the 0.6 over here means that 60% of students who failed, because notice we're in the fail row, 60% of them did not study. So that's just to put these numbers, what do they actually mean? That's what they mean in the context of this situation. Okay, so what if it asks you problems about joint and marginal, finding these conditional relative frequencies? I admittedly have just realized that my title is a little bit off here. It should still say finding, or it should say finding something like finding conditional relative frequencies. So I'm very sorry about that. But anyway, the question and the strategy is fine. So here's a table displaying the joint relative frequencies that we saw before. It doesn't show the marginal ones. We actually don't need them. They would make it easier, but we don't need them. If we randomly selected a student who studied, what is the probability that the student passed? So basically, we're not thinking about the entire total, which is normally out here. We're thinking about out of just the students who studied, like what percentage of them passed. So there were, this relative frequency is 0.68. That corresponds to those who passed under the studied category or the study category. And then everything under the studied category is these two added together. So we're doing the number that passed, that studied, divided by the total number that studied. These two add up to 0.76, or these things in parentheses over here, and then this comes out to about 0.895, so that's about 89.5%. So if we randomly pick a student who studied, there's an 89.5% chance that they passed. Okay, now what if they ask something like this? If we randomly select a student who passed, what is the probability that the student did not study? So now we're thinking about, out of these students who passed, what percentage did not study? Now, we're not reading directly from the table because these are relative to the overall total, not the row total, which is what we need in this case. So let's think about it. What's the probability that they did not study given that they passed? So we take this 0.12 for students that did not study and passed, and we divide by just the total number of students that passed. So all of these two put together is the amount that, the total, that total frequency that passed. Okay, so total that passed, and then those that did not study that passed on the top. So this comes out to about 0.15, and that's 15%. So if we randomly pick a student who passed, there's a 15% chance that they did not study. And we actually already, if you remember, which it's fair if you don't, but if you remember the table from a little bit further back, we actually already knew this. When we made our conditional relative frequencies, we actually found that already, that 15% that passed did not study. Okay. That is a lot of vocab. When I post the slides, I will update the titles up here in order to help you with that. Yeah, please refer back to here, these slides or this video, if you have any trouble remembering the vocab, because it will be in here. Good luck with the assignment. And as always, I hoped these slides provided at least a little bit of help. Have a good one, everybody. Goodbye.